Okay, we are back again, and this time we're going to continue back with this ridiculously silly project that has no purpose whatsoever other than for me to learn a few things. So this was my 4049 RS flip-flop latchy thing, which is pointless because if you're ever going to do this, you're going to do it with a 4011, which we haven't done yet. Which makes all this kind of work much easier. But I want to get this thing to work the way that I want it to work. So anyway, first off, we've got the little two buttons. So we're going back to this. And so the last time I looked at this thing, I tried to attach this thing, and then I had all this complicated stuff where I was going to have two, and then they were going to have like interfering patterns, and the light was going to look like this. And then the whole point was, instead of having two buttons going into the so when I press the button, 5 volts goes into here. I've gone and lost my piece of paper with all the pictures on it. So you'll just have to look back to the previous videos. 5 volts goes into here, and if it goes on this side, the light comes on. If it goes on this side, the light goes off. But the problem is that if you're connecting this digitally to like another IC, you're not going to get. So when the button's not pressed, you have an open circuit. So it's not actually being pulled anyway or anything like that. So it isn't part of the circuit when the button is not pushed. But in an actual digital circuit, you would have it either being a low output or a high output. So what I'm trying to do is adjust the circuit so that it would work with a high or a low output thing. So when these wires, these two wires here, are receiving a low input, it shouldn't have any effect on the light over here. If that kind of makes sense. Well, I'll go back to the previous video and then it will make a bit more sense. And I've lost my silly picture, so I didn't really prepare it well enough for this today. But that's okay. So the point here is, I tried to do a digital signal coming in with these things, but it was very confusing. So I'm going to make it much simpler, and I'm going to provide a digital signal via this little IC here. And I've only got a couple of these, and I'm sorry, kind of surprised that I even found this one, because it was hidden away. Like, it was in my little book where I write down everything that I've got, but it was in a random pile of ICs that I picked up secondhand from a long time ago. So the fact that I found it is impressing me. But what is it, you might be asking? Well, it is right next to the 4049. So this is the CMOS cookbook by Don Lancaster. On the 4049 page is the hex inverter, which we've been looking at a lot. But on the next page, there is the hex non-inverting buffer and TTL driver. So this is just like the 4049, except in this case, instead of inverting the output, it just does the same thing. So when you put a high voltage, say, onto pin 14, then you get a high voltage on pin 15, and if you get a low voltage on pin 14, you get a low voltage on pin 15. So I'm going to take the output of this pin, and I'm going to stick it. I do feel like I really do need to have. We're going to use another one of these just so that it looks a big mess. And we're going to keep it like, it is going to look like a big mess. So here's my 4049, and I'm going to 4050. We're going to stick it here, and this is going to buffer the signal. And then we're going to use a trick. Well, we're going to learn about pull up. I'm going to break this, aren't I? It's going to get electric static something or other, and it's not going to work. I should have got out my. I got this. Another thing I managed to pick up randomly was an IC tester tool. But that's being hidden away. It's not going to go in. And I keep forgetting to try and find, as I think I mentioned, there's a little tool you can get, which is well worth it, which straightens the legs up so that they fit in these things. And so that's handy, because they're very easy to break. And I don't want to break this one. I do have my IC extractor tool handy. I've gone and lost it. It's right next to me, I'm sure it is. I can see it. So for taking them out. So I can take them out with this thing, and that means I'm not gonna ruin the legs like I did the last time. We're also going to learn about pull down resistors. So the buttons aren't going to be. So the trick here got a lot of wires all over the show. Well, these two wires are coming off. Alright, and these wires, actually we're going to move these two buttons over to here. So they're coming off here. So I don't know how long this video is going to take, because it's going to think. So these are my inputs here, these two bits here, if you can see them, going into the diode. So I was hoping the diodes are going to fix everything, but I don't know if they will. And instead of actually sitting down and drawing a piece of paper, drawing a picture on a piece of paper and trying to work it out in my head and trying to suss the whole stuff out, I'm just going to try this and see if it does work. Because that will be more fun. And this is the only chance I have, I think, of doing a video about a 4050, because it seems mostly to have a limited use. Because if I ever do need to buffer a thing, you can just put it through a 4049 twice. So if you invert it twice, you get back to what you originally had. So let's just quickly have a look at, I'm not going to do this completely properly. So the very first thing we have to do is, well, we're going to have to link these two up, because it's all going to, we're going to turn this off so we don't damage something. So I was mentioning that Julian, I forgot his name, well, he was, his video, in the last video I did, I mentioned him, and he broke something by changing it finally, and then he was all like, oh yes, there are some cases where you can break things if you change the components around while there's still power applied. We're going to keep that off for a second. Ooh, I have to dig up some. Oh no, that's okay. We can do that. Okay. All right. So I've linked those two together, but I haven't actually linked that rail to that one. I was going to use this thing. These are all my spare little cables and wires and bits and pieces. And these are my little handmade ones, which never look quite as good as the other ones. I don't think the wire is quite as thick on my handmade ones. They all come from these things. It's well worth getting some single core wire like this if you can find it, because then you can cut these things to your own length. Alright, so we have got this, it's powered up, but we still haven't connected it up. And I'm just going to do that real quick. So this one is pin number 1 over here is the power line, so that one's getting some power, and I bet you that, oh no it's not, where's a good wire? There's a good wire. So this should be quick, we can do this, we're only on 10 minutes. And then the other one over here. So these are kind of funny ICs, because I think there's a standard way they go, and I think the two power things are usually on the opposite sides. Let's just have a quick look at another one. Yeah, so on another one like a 4030, they're quite often on opposite sides, but on these ones, they happen to be on the same side. So the positive's going into, oh dear, what a day. I just had the ground going from the positive rail, which means nothing would actually happen. You won't blow something up doing that, because they've both got the same potential level thingy. So now what we've got to do, we've got to take, so one output is going to come from my button, and that's going to go, let's just have a look at the picture here. So we are going to use, they're both exactly, they're the same pin layout, so that's quite handy if I get the wrong page. So 3, we're going to go into pin 3, and then pin 3, we're going to do this ugly style with lots of wires everywhere. Lots of big dopey wires, because we're going to have wires anyhow, but I mean not little small neat and tidy things. Or I feel maybe I should do it for that one, shouldn't I? Because we can do it. Alright. Is it going to reach? I feel like, do I have the patience to try and get them the right length? Well, it turns out that one is kind of roughly the right length. No, it's not. No, it's not going to be worth it. Sorry, you're going to have big giant wires everywhere. But I will explain it. So I've just attached a wire into here. It's going through there, and then that one's going to my digital input there. And we're going to do exactly the same thing over on this one. So that one, but I haven't wired these buttons up properly yet, so don't jump ahead and say that nothing's going to happen because the buttons. So that one's going there, and then we'll take this one. Oh, it's very confusing here. Alright, I'm going to zoom in. You can have a good look if you really want. That's an official RCA branded 4050. So if you can kind of see it. If you want to see that kind of thing. Maybe you don't. And we've got this bare wire here. Now, the trick is, we need two tricks, don't we? The first thing is, so that one's going to go, well, I'm going to jump that across. There's a lot of wires bridging power rails here, isn't there? But that's okay. So this one, so there's one extra thing I have to do, which is to pull down resistors, sorry, and we're going to quickly talk about those. I do feel this did need to point at the diagram on a piece of paper that I drew, but it's probably, I have a folder, I'm looking right behind me and I can't see it, where I put all the pieces of paper that I make up and for later reference. Okay, so the positive power rail is going along here, through there, over there, through there, around here, jumping over to here, onto here, into the button, and into through here. But the one thing I want is that, again, we're back to the same problem, that if I don't press the button, it's an open circuit, so that pin won't be connected to anything. So technically I should actually connect all the inputs that I'm not using to something, whether it's ground or 5 volts. It doesn't matter too much. It's just that they should be consistent. But that's the main reason is that this thing will be using more power if you don't tie the unused inputs to something than if you did, because these things use up more power when they are changing all the time, and if they're not tied to anything, then they could be randomly changing. And I don't want this one to be randomly changing, so I'm going to use a thing called a pull down resistor, which means I need to find a box full of resistors, and it needs to be quite high. So the idea is, I may have to do a video. I'm going to do a video on this. We'll just use 12K. You should be quite high, but I'm going to use 12K just for the fun of it, because they just happen to be there. So in general, I'll try and show what's going to happen. This is definitely and this is what you get. I'm going to put this over here, so is that a bit easier to see? Or now there's just shadows everywhere. Going to make sure the thing's not flickering. So it doesn't like some of those lights. My camera doesn't like some lights. It makes it the camera starts to flicker if you put certain lights on. So the trick here is there is going to be 12 volts going, 12,000 ohms resistor in the way. So there is a path automatically to ground by default. So this, you can imagine the path is going. So here's the ground rail, goes through the resistor, back over this wire and into this chip. But for now we'll just say, we'll go through the actual maths of it a bit later on, I think, but not in this video. But when we press the button, then you'll get a 5 volts going in, which has no resistance, so it's sort of going to overpower it. So this is like weakly holding it down to ground, and when you press the 5 volts you override that and then you get 5 volts into here. So the whole point of this is that this will be either low or high, and it will give a low or high output, a nice clean low and high CMOS sort of level output, regardless of what I was doing over here. So it's sort of cleaning everything up. That's why it's buffering everything, I guess. And then it's going to go into here, and then we're going to see if it still works when I press these two buttons. So I think I have wired everything up the way it needs to be. Hopefully this works. So let's just find out, because I want to get this out of the way so I can finish off my Pong game. Alright, let's do this. I'm going to turn it on. The light's on. If I press the button, nothing happens. Oh, it went off. It went on. It went off. It went on. It went off. It went on. It went off. So there we go. It works. It actually works. So I think that is the completed way of making a RS-LATCH with a 4049 instead of using like a 4011 or the 4001, which I think is the NOR gate. I keep forgetting. But those are the way they commonly do it. If I had my book available, which the other book, I'd show you the circuit for that. But we're going to do that when we do 4001s and 4009s. 4011s. What is the 4009? Do I have one? Let's see if we actually do that one. It's a hex inverter. Oh, that's right. This is the old style. It's the same as this one, but it's like a 4049, but it's the old one, and apparently it does bad things. Will self-destruct. That's right. So you can. This one was much easier to break. So it will be hard to find any of these. I doubt that I've ever picked up any of these. But I do have some surprises and some rare ICs for later videos, but not that one. So there we go. We finally used a 4050 for something. So now I can add that to the list of ICs. So I hope that was interesting. It was interesting for me. It probably isn't for anyone else. So thanks for watching, and like, share, and subscribe.